Okay. So, okay, you need to calculate loop gain for this circuit.
Okay. So what I can do for loop gain, we can short circuit. I mean, we can ground the input here. We can ground this, and this VDD also can ground with and for loop gain, and we will apply a VTest here, and we will find a VF or how much it is actually getting amplified, something like that. And loop gain LG would be minus of V final by V test, that is V initial. We have applied that actually will be loop gain. So here, uh, if this is grounded, so PDT is not there, that is 0 volt, and there also it is 0 volt. Current will be down minus GM into V test into V test. So the voltage V output will be uh, minus GM, so minus GM into V test into RL, and that voltage will be appeared here. So we know that V positive minus V negative AS, whatever that is, equal to V output for an op amp. So V minus GM minus GM into V test.
What is the loop gain now? Complete expression. Hello. Hello. What is loop gain then? Hello. Can you are not audible? You are mute. You are muted.
Yeah,
Okay.
yeah,
So what is the
it's
loop
not
gain
fine.
form?
A in A into V test. So VF by minus VF by V test equal to into RL into A. This is supposed to be a loop gain.
Okay. Fine. Let's go for the question number 3.
Okay.
Okay. So what I need, oh, this is fine. So the current source is some practical current source, not ideal. Practical current source. It need minimum voltage of, let's say, some 100 millivolt to be remained as a current source. This is your 1.8 volt. Okay.
Millivolts.
Okay. So still the concept. So this is a current source which is practical. It needs minimum 100 millivolt across it to be remained in like a saturation or proper current source. Okay. So the VTH for the device is zero point 0.5 volt. VTH for the device is zero point 0.5 volt. So what I need minimum input voltage, minimum input voltage and maximum input voltage so that your transistor can be used as a amplifier. You got the point? You cannot apply any voltage at the input in the maximum side, or you cannot apply any voltage on minimum side if you want your transistor to be in saturation or to be in amplifying region. So what is that range that I want? Input common mode range. Minimum and maximum value for the voltage so that you can use this transistor in your amplifying region.
What is 100 millivolt? Okay. So actually, this type of concept I didn't learn.
Hmm?
So can you give some hints so that
Okay,
actually this type of
so
concept I
okay,
didn't
okay.
learn.
So
So can you give some?
not a problem. So as of now, you are in the like final year, so it might not be easy. Anyway, I'll leave this. I will leave this. I'll take new question. So third question will take new question only. It is VDD. It has some R naught impedance. Current source has R naught impedance. V out. So what is the GM for the circuit and gain?
Okay. GM means I out.
Current source is practical. It has R naught. I want GM and gain.
Okay. GM is transconductance, and this is VO by I in, right? GM equal to,
Hmm?
sorry, it's opposite of resistance. I out by V in, right? GM equal to.
Hmm.
Okay. V. Okay. This is I naught, and here to find out GM. So okay, this is let it be Vx. So here small gm into V minus Vx current will flow. Gm into V
What is GM? Which is I
small
naught here.
gm. Yeah. Okay, okay. sorry, sorry. Then okay, this is then I naught, and here what is the value of lambda?
Lambda you can take as 0.
Okay, that means no R naught is there in between. Okay.
What's the definition of GM?
Hmm. GM delta ID by delta V in actually, or delta VGS here.
What's the definition of GM?
GM is trans conductance.
Oh,
So
that is a transfer,
um,
that is
I
fine. But in any transistor, if you are
yeah,
calculating GM, then what we actually do?
uh, differ differentiation of output current with
Oh, that is
respect to
fine. That
input
is
voltage.
that is good. But usually when we calculate GM for the circuit, we also call it short circuit transconductance. Short
Okay.
circuit transconductance. It simply means when you want to calculate the transconductance of the entire circuit, then you need to do input is here. You need to R naught anyway. R naught is given. You need to short the output and you need to compute this short circuit current ISC. If you are shorting the output,
Hmm.
any
Hmm.
DC should also be like shorted. VOUT is also, VDD is also shorted. So anyway, this current source has no meaning.
Hmm.
So effectively, you can say you have to compute. You have to compute short circuit current. Okay, and you have to compute short circuit current as a function of V in. So you can see this is the source. Let's say body is also at ground, and what you can simply see, you can write the equation for ID. ID of any transistor can be written as GM VGS
Hmm.
plus GDS VDS plus GMB VBS is a general equation. Put everything in place. You will find that ID equal to minus ISC. You will find everything in terms of GM.
Yes,
VG is what? V in. S is what? This potential S? This potential is minus ISC times R naught.
minus I into R naught.
ISC times R naught plus, so everything you put in place and you will find it ISC,
Hmm.
and you have to find the ratio ISC by what you need to say V. That is a short circuit transconductance, which is the transconductance of complete circuit. You can see when we directly define now for any transistor, let's say this is a simple transistor, and we know that for this, what is the transconductance? We say GM only. So how it
Hmm.
comes? Simply we apply the same concept. Let there is input
So,
voltage you are giving to this transistor, and with this input voltage, let's say you are like anyway you are plotting this ID. Okay, this ID is coming with the input voltage, some sort of this is coming, whatever is coming, like ID, not exactly like that, whatever. So if you are differentiating it, so dID by dV in whatever is your transconductor definition. So
hmm.
this is the definition that when you plot the current for different V in, keeping this VD at some potential, this potential is let's say some V, I mean to say some VDS, for some VDS, let's say VDS of 1 volt. This we are drawing ID versus V in, and we are taking the differentiation of that particular curve, and we are getting the GM. This is the mathematical.
mm,
But when you are computing or when you are calculating in like circuits, then what you will do? You will nothing but short circuit the output, and you compute this short circuit current or even the ISC. What the ISC here? ISC is nothing but simple minus ID itself. What is the ID? ID is GMV. So what the ratio of ISC by V in? That is coming to be minus GM. Or simply by magnitude we say it is a GM only. That is the transconductance which is usually known as a GM. So when there is the entire
okay,
some other things are connected, resistor and all other things, then the concept is same. You need to short the output and compute the output short circuit current as a function of input voltage. That is the transconductance, short circuit transconductance.
mm,
Okay. So this is the concept. Next, take the next concept. Okay. Let's take jump again. There is some offset voltage that I call V offset. Okay.
okay,
And okay, better to instead of taking capacitor, I will take resistor. Hmm. Okay, this is R1, this is R2, R1 equal to R, R2 equal to VR. So I want V out. The expression for the V out in terms of input voltage and offset voltage.
okay. So, as we know that it is a negative feedback op-amp, so short circuit here, virtual short circuit concept will be applied here, and this V offset will be applied at this node. So, whatever the current that is going from V into V offset, that would be uh, V in that current, that would be I, V in minus V offset divided by R1, and this current will also flow from here to here to output. So um, the output, sorry, what is happening? So V output with V offset minus output equal to V offset V offset V offset minus R2 into I, R2 into I. That means R1, R1, sorry, R1 into V minus V minus V offset. Yeah, this supposed to be the output.
Okay, so you can and in terms of offset voltage and okay. So how much gain you are getting with respect to offset voltage only? How much output voltage you are
How
getting
much
due to
gain
offset
I'm
only?
getting?
How much output voltage only? I am requiring output voltage due
Okay.
to offset only.
For offset, this is V offset into 1 plus R2 by R1 to R1.
Okay. So that is the output voltage you are getting due to the offset. And
The
how much output you
offset
are
into 1
getting due
plus
to
R2 by R1.
that is fine. How much output you are getting due to input only?
That is minus R2 by R1 times input.
Then why didn't you apply the superposition at that time? You went through all this node voltage, KVL, KCL. Directly you have two independent input sources. One is offset, one is input. Calculate output for each, like individually, short one at a time. So superposition simple, and you can compute. Otherwise, if there are two, three voltage requirements there, and you will apply KVL, KCL all the time, then complexity will be there. So better to apply the superposition in such questions. Okay. Okay. So yes,
Mm.
input okay, output voltage. So have you learned about operation amplifier internal structure?
No,
Internal
actually,
structure of operation amplifier. It is a five transistor OTA and all.
acha, this should be like mm,
You know something about that?
we'll apply a V in yeah internal structure of op-amp, like you are wanting from that MOSFET analysis or just again
No, no.
some input voltage we are applying here, like this is, let's say, registers, and here's some input voltage we are applying.
That is okay.
uh,
That is like a model only. That is a
uh,
model.
and here
That's the model. Okay, not a problem. I will not go there. I will simply take one more. Plot the output
plot the output, right?
with respect to time.
Okay.
I need to give one more thing. BTH equal to zero point 0.5,
This is 5 milliamps. This
lambda
is
equal to
offset.
0.
No. Okay. So here no current is flowing through this MOSFET, that is 0 amps.
Okay.
So all the current will flow through this R and C networks.
Okay.
So uh,
All the current is flowing
the
across.
output should be all the current will flow across this capacitor, and I think some current will flow from here also.
Why? And how much?
some of the current should flow from here.
Why some of the current here?
Now, uh, VGS. Okay. If
You note it down on a notebook and
just we
practice
can
it in free time. Analyze it properly. Let as a RC circuit, and because extra thing there is only the MOSFET. Rest everything is simple R and C. Step current.
what is step current. So at that um, instant, uh, at t equal to 0, this would be the short circuit. So VO would be 0.
What will be the V out initially?
VO at get increased.
Oh
And
no, no. At t, that just at t equal to 0 when we are applying the step current, what the status of V out?
V out should be 0.
V out should be 0. Then what about the gate voltage of amplifier?
This is 0. Um, 5 million current will flow through here 0. So that is V equal to I into R. That is 5 into 1, 5 millions into 1 kilo. That is 5 volt.
5 volt.
Here,
So gate
so
is at 5 volt. VTH is zero point 0.5 volt. So we have VGS minus VTH of 4.5 volt. We have very less VDS near to 0. So what is the reason of operation of amplifier? Sorry, what is the region of amplifier means region of operation of MOSFET initially?
initially the MOSFET will be in the saturation region
Saturation. Why?
because VO is
What is the condition for saturation and what is the condition for linear of amplifier or of
0
MOSFET?
and the current V
No, what is the condition for MOSFET to be in saturation and to be in what so triode region? What is the condition MOSFET to be in saturation region? Anyway, you think about this question. I'll take next question. You can think about this. One simple question I'll take. Okay. So region of operation of M, sorry, MOS, one thing. And let it take as a zero point 0.5 volt. We have to tell the region of operation of MOSFET. What will be that?
this is VGS minus VT is 1.5 volt, 1.5 volt. Okay, so this is in the trial region.
It is?
Trial.
Okay, it is in
This is
triode
in the trial
region.
region.
So what is the maximum gate voltage? What is the
Maximum gate
maximum
voltage.
gate,
Okay.
wait, what is the maximum gate voltage so that this MOS doesn't go out of the saturation? This is the 2 volt I applied as of now. Now I want the condition for
Mm,
maximum gate voltage so that my MOS doesn't go out of the saturation.
okay. So for that, VGS out of the saturation, so doesn't go. Though, so that means the MOS will be in the saturation region, right?
Yes.
So VGS minus VT has to greater than VDS. So this is 2 volt. I'm sorry, not this 2 volt. This is VG minus 0.5. What is just minus 0.5 is greater than VD. VDS is 1 volt. VDS is 1 volt. So the VG has to greater than 1.5 volt.
If VG is greater than 1.5 volt, then what will be the operational region of MOSFET?
Saturation.
If it is greater than 1.5,
Hmm. Sorry, in the triad. So for saturation, it has to less than 1.5 volt.
so it should be less than 1.5 volt. Okay, for it to be in,
This is for the triad.
this is for the triode. But if we want
Yeah,
not go out of the saturation, then it should be lesser than 1.5 volt.
lesser than 1.5 volt. Yeah.
Okay. So what is the minimum value of gate voltage so that my transistor is in working mode?
So VGS has to greater than VT. So
Hmm.
that is VG has to greater than VT. So 0 0.5 volt.
So what is the gate voltage here you are getting to remain in saturation? Some range you are getting?
From 0.5 to 1.5 volt, the MOSFET will be in the saturation. After
Not,
that, it will
no,
go
no.
to,
It is not fixed as saturation, but yes, yes, is a range. Yeah, it is a range. Yes, yes, fine.
yeah.
It is working for the VTS greater than, sorry, VDS greater than, sorry, VGS greater than zero point 0.5. This is a working. And
Uh,
if it is lesser than 1.5 volt, it is in saturation. Overall, the range of saturation is this. So the question
uh,
on top that we left during the discussion was this only. So for what range of
acha,
gate voltage our transistor should be in saturation, because amplifier can work only in the saturation. So
acha, okay.
when we want any transistor to work in the saturation or to work as an amplifier, we need to operate in the saturation. And what is the range of the gate voltage that we usually call the common mode range, input common mode range?
Acha,
You
okay.
cannot apply input much more than that maximum value, and you cannot apply input lesser than the minimum value. Otherwise, you cannot take the advantage of an amplifier action of the MOSFET.
Mm,
This was the concept I tried to clear there. So, any idea about the device physics?
mm, Device physics, I mean semiconductors and all.
MOSFET on device structure level.
Yeah, I think some basics I have learned. Piece of
Okay, so let my gate is at 1 volt, drain is at, let's say, 2 volt, source is at ground, and body is at 1 volt. Okay,
mm,
so which particular diode in this MOS structure will be conducting? Which diode? Is there any diode will be conducting? If you have any idea of device physics, can you tell me where are the diodes in this structure?
I I don't know what the diode is conducting. I mean, this type of device phase I didn't learn.
This is the MOSFET only. This is the
Huh,
MOSFET only.
that's
So
fine.
if there is a P on one side, there is a N on other side. That is the formation of diode. P and N. P and N. So this
That
is
is
the piece.
that.
Yeah, this is the P substrate. This is the N. So there is a one diode here.
Hmm,
There is a
hmm,
one diode here.
hmm.
So which diode is conducting?
This is plus, this is minus. So I and this is 1/2 also. This that is conducting.
Yeah, that was the question only.
Yeah, this that is conducting.
Okay, so I think as of now we have covered many things. So you can revise somehow. I can give you the feedback that overall it was good, but you need to look a little more and be calm while you're answering. Don't be like hesitate in front of interviewer. You will feel this thing
Yeah,
that they
hello.
met. Hello.
Yeah, Anuj, I have some couple of things to ask. So after that one, can we conclude?
Oh wait, then I think I need to launch one more session because it is about to over. Only 1 minute is left.
Okay, okay. Then in the new
Yes,
session,
yes.
I will start asking.
Okay, okay. So then I will conclude.
Okay, okay.
Okay, fine.
Go for it.